Alright, problem number 5. On the planet Schefflera digitata, a teacher writes the following equation on the board. Alright, she writes 13 plus 15 is 31, 10 times 10 is 100, and 6 times 3 is 24. How many fingers do the inhabitants of Schefflera digitata have? Alright, well, we're going to assume a lot of things about how the inhabitants of Schefflera digitata count. Okay, we're going to assume that they count pretty much just like us, except that they have a different number of fingers. Okay, so we need to think about how we count. Okay, we have a base 10 system, right? We have 3, 4, and a thumb. We've got 5 fingers on each hand, right? So here's a thumb. 1, 2, 3, 4. Those are funny looking hands. But so let's think about how we count. We use the digits 0 through 9, right? And we count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then what do we do when we get to 9? We use a place value system, right? And then we have 10. Okay, so we actually, we could start with 0, all right? And then we use the tens place to keep track of how many tens we have. So we have 1 10 and 0 ones, 1 10 and 1 1, 1 10 and 2 ones, okay? And so this base 10 system is based on our 10 fingers. Okay, we have 10 digits, right? A digit is a finger, right? So a digit is a finger, or it's a digit. So that's where that comes from. All right. So let's think about what's going on here on Schefflera digitata. So however they count, that we're going to assume that they're obviously using the same digits, at least for some, they're using a 3 that looks like our 3, they're using a 5 that looks like our 5, they're using a 1 that looks like our 1. So, so let's say, for example, here's this little monster here. We don't know if he's actually from the planet Schefflera digitata or not, but if he's got 6 fingers, so how would he count? He would count using a base 6 system, right? So he would use the digits 0 through 5, right? 0, 1, 2, 3, 4, 5, and then when he gets to what we call 6, he would say, okay, I have 1 6 and 0 ones. I have 1 6 and 1 1, 1 6 and 2 ones, 1 6 and 3 ones, and so on. Okay, so what he calls 13 would be equal, so this is in his base 6 system, I'm going to put the little subscript, 13 base 6 is equal to what in base 10? It's equal to 6 plus 3, which is 9. Okay, so in base 10, I should put a little subscript on that too. Alright, so let's think about what's going on with this first sum. So we have 13 plus 15. So we're assuming they do everything just like us, except they have a different number of digits. Okay? We have 10 digits that start with 0 through 9, and they have some other number of digits. Okay, so let's take a look. So they added 3 and 5. Now the answer was 31, right? So they added 3 and 5, and they got 1, and they would have had to carry a 1, right? So essentially, in their system, 3 plus 5 is equal to 11. Alright, so that's equal to 1 of whatever their base is, plus 1 more. Okay, now in base 10, 3 plus 5 is equal to 8, right? 8 in base 10. So, in order to get 11, how many digits must they have? They had to, the digits ran out at some point, and then they started keeping track of the, however many digits they ran out at with this place value, and then they added one more. So 8 is equal to 7 base 10 plus 1. So this first number right here has to be the 7's place. Okay? Just like over here in our base 10, oops, that wasn't base 10, was it? Get a different one. Here was our base 10 system, alright? We counted up to 9, and then we ended up with 1 10 and 0 1s. 1 10 and 1 1. Alright, so this counted the number of 10s, and this counted the number of 1s. Alright? And in their system, this still counts the number of 1s, but in order for this to work out, this has to keep track of the number of 7s. So they must have a base 7 system. Alright, so they have 7 digits: 0, 1, 2, 3, 4, 5, and 6, right? That's 7 digits. And then when they get to what we call 7, they have to keep track of their 7s in another place value. So this would be 1, 7, and 0 1s, 1, 7, and 1 1, 1, 7, and 2 1s, and so on. Okay? Alright, so just based on that, it looks like they must have 7 fingers. Okay? They have 7 digits, so they must have 7 fingers if they count just like us otherwise. Alright, now we could take a look at these other problems. Okay, so we could look at 10 in base 7 would be what? It would be 7 in base 10, right? Right? Because this means in base 7, this means they had 7. They had 1 7 and 0 1s. All right. So 10 times 10 in base 7 is 100, just like it is in base 10, but it's okay. So if we were doing this in base 7, this would be 7 times 7, which is 49. So let's take a look at the place values here. So now in this case, here this is still the 1s, and this is the 7s. Okay. And when we get 7 7s, then we have to keep track of them in another place value. So this is actually the 49's place. Okay, so actually 100 in base 7 is equal to 49 in base 10. Okay, so it works out. And you could do the same thing with 6 times 3. So essentially you're adding 6 plus 6 plus 6. So if we add them, first of all, how would we count? We'd start with 6, and then we have 7, but that's really 10, right? So, and so you add, I'm adding here. So you would count 6, and then 10, 11, 12, 13, 14, 15. So 6 plus 6 would be 15. Alright, in base 7. I should make this base 7. The Schefflera digitata base. Okay, and then if we add 6 more, okay, because I'm trying to get 3 times 6, right? So if I add 6 more, okay, we'll start with 6. Now let's add the 5. So we had 6, 10, 11, 12, 13, 14. Alright. And so carry the 1, and 1 plus 1 is still 2. So you can see that in base 7, 6 plus 6 plus 6, which is 6 times 3, is 24. Okay? So it checks out. So, number bases are kind of tricky to get your head around, but it really makes you think about how our own base 10 system works. Okay? Because we sort of take for granted. We start learning how to count in base 10 from the time we're little kids, and we forget that, or we never know that there there might be another way to count. So it really makes you think about how numbers work. Okay. So anyway, there you go. Let's see, what was the answer here? Oh, it was base 7. so, so the inhabitants of Schefflera digitata have 7 fingers because they use 7 digits to count in base 7. All right, so there you go.